Hi, so let's start our first class in this mode. I'll continue from where we left off last time and repeat some few things to build the background. So what we're trying to say is we're going to be able to predict what are the images and what is the nature of the image, okay, um, that we see in mirrors. Okay, we've already discussed plane mirrors and now I'm going to focus on convex and concave mirrors. And what you need to understand is you got to make sure that you've seen one, otherwise it's going to be difficult. Okay, one simple thing that people always say is look at a spoon. Look at a spoon. This is a bad drawing of the spoon, but let's see, like this. Okay, and now you see, if you look at this side of the spoon, then it's going to be a concave mirror, and if you look at it from the other side, then it's going to be a convex mirror. And many of you may have already seen, we've looked at the videos, and we looked at the kind of images that we expect, and you can do some experiments on your own. So can we predict what we see, or can you understand why we see what we see? That's the goal. Now, just to one more way of looking at the mirror, just think of a tennis ball. Okay, I don't know how tennis ball. Okay, some tennis ball like this, and hollow tennis ball, and then you just take a slice of the tennis ball like this. So you get some bowl-like shape. A bowl is a very good way of imagining this. And if I silver it on this side and look from this side, then it's a concave mirror. And if I silver it from the inside, and look at it from the outside, then it's a convex mirror. Okay, and this is another way of imagining this. And upfront, let me tell you that every convex and concave mirror is going to be associated with the center of the ball. Okay, so this is the center of the ball. Right now it's somewhere here. Now this distance, which is the constant because it's the radius of the tennis ball or the radius of the sphere, is called the radius of the mirror. Okay, this is called the radius of the mirror, and usually this is known. So when you go to the market and you ask for the nature of the mirror, then they'll tell you the radius. So now, given this information, given the fact that you know which side the silvering is done, can we predict the nature of the image? So that's the fundamental question. Can we predict the nature of the image? Okay, so you pretty much know how the mirror has been formed the moment they tell you the radius, right? So now we're not going to draw 3D pictures, we're just going to draw the lenses like this. Okay, now this is silvered from this side, and now I told you last time the convention is to keep the object on the left. So there's an object here, AB, and what is it? And you're going to watch from here, so obviously, and watching. So then we typically draw the eye. I think I'll stick to the Russian way of drawing the eye. Okay, then this eye perceives something in this mirror, and can we predict what this eye sees? Okay, now the other way around is a convex mirror, and this time it's once again the object is to the left, the eye is to the left, and can we tell what we're going to see in this mirror? So that's the base question, right? So now there is a sign convention. So how are we going to achieve our objective? And what I told you last time is how. Okay, now there is a slight bit of confusion. If you want a really straight answer, what is going to decide is just one fact, which is the law of reflection of light, which we already know now. We talked about in the last class, and a little bit of geometry. Okay, now these two things actually give us a formula which can be proved. Okay, the formula is not a law, it's a consequence of the law and a little bit of math. But we are going to jump to the formula, and so here what comes here is a proof, which for the time being we shall ignore. We'll do it sometime later. Okay, now at the end of the day, the end result is that I can easily predict what I'm going to see. So this is what we're going to learn, how to use this to predict. And what's inside here is the so-called mirror formula. Now there are two in number, which sort of contain the whole story. The first one says 1 over f is equal to 1 over u plus 1 over v, and the other one says magnification of the image is equal to minus v by u. Right, now implicit in using these formulae to get your predictions is that we all follow a convention. Okay, so let me just focus on the convention first. The convention is universal, it's used all over the world. All over the world, the mirror formula is the two is the same. So what is the convention that we're going to follow as the rest of the world? Now we're going to discuss that, but before that, once again I say, when I say mirrors, it means both convex and concave. And yeah, plane mirror is particularly easy, so you don't have to worry about it. Alright, so here we go. So the convention is that the object is always to the left. Okay, now which means that we're going to observe in this direction. So this is the eye. Okay, and we're going to observe in this direction. Now the mirror is going to be placed like this. It could be okay, let me just discuss this. This is a convex mirror. Okay, or I just draw the concave mirror also on this side. Okay, the lines here are for telling you that this is silvered on this side. Okay, now this is called the optical center. Okay, where the horizontal line meets the mirror is called the optical center, and O can stand for optical center, but more importantly what we'll see is the convention is that O is the origin. So optical center is also the origin of something that we've been talking about a lot, and that is the coordinate system. Now, the moment you draw the coordinate system, things are going to be very clear, in the sense that now it's clear that first everything is going to be measured from the origin, which is our usual practice. So all measurements are from the origin. Now this is our usual practice in coordinate systems, so great. And there's a couple of other obvious things now. This is, if you measure in this way, it's positive. If you measure in this way, it's negative. So, and if you measure in this way, it's positive. If you measure in this way, it's negative. So such a very easy convention to remember. And we're almost done, I think. So it's time to practice what we've just learned. So for example, it is understood. A couple of things are obvious. I'm going to write it down here. A couple of things are obvious. One is that okay, what is this? This is the convex mirror. One is that the object distance, which by the way we are calling it as u. So u stands for object distance, is measured from here till here, and let's call it something. Let's call it u, and it's very obvious that u is always negative. Okay, always negative. That's by convention. Now we don't know about v yet, so if v is on this side, okay, if v is on to the right, then it's going to be positive. If it's going to be the left, we're going to be negative. So let's not worry about it up front. Okay, now what is also clear in this particular diagram is that the center is somewhere here. Okay, radius. So by convention, the radius is positive. So I'm just going to write it here. Radius of convex mirror is equal to positive. And by similar reasoning, radius of concave mirror, maybe I just draw it in the next slide, is negative. So these are things you will get committed to memory after doing a few problems, but these are obvious. Okay, so let's summarize again. I got a formula, and up front we're raising a flag. We know now what u is and v is and what f is. I haven't told you what f is. So f is equal to half of the radius. In other words, if I know the radius, then I know f. F is called the focal length. So f is focal length. And the sign convention is absolutely the same as the radius. So here I go. F is focal length, which is r by 2. Okay, now a couple of other obvious things. U is always negative. And I've been now trying to convey the point that anytime you look at a physics formula, the unit is important. Now u is obviously meters or centimeters or whatever, but usually it's centimeters and meters. Okay, now what about v? Now it's important to stick to the same unit throughout the formula. V we don't know yet. It depends on which side the image is formed, and the unit is again obviously meters or centimeters. F is pretty much the same story. Now F is negative for concave and equal to positive for convex mirrors, and again the unit of F is meters or centimeters. Okay, so this is the formula. The only caveat or the only flag here is that make sure that you use the sign convention. We're pretty much done with the sign convention. The main thing about the sign convention is that use the coordinate system. Okay, so can we start applying what we've just learned? So I'm going to write here. There is no end to the number of times we'll keep talking about this. It's worth talking about it. What is this formula trying to tell us? First of all, why is it true? So it is true because there is a proof. The proof just requires the law of reflection of light, and therefore it is highly I have told you this last time that, well, it's proof, but it's nearly right, not perfectly right. Nearly right, and nearly right is good for us, right? And now there is another formula which we are going to use, and that is magnification is equal to minus v by u. Now this also desires you to use the sign convention, and once again this can be proved very easily with the help of the law of reflection. So what is this formula trying to tell us? So let's see what is the implication of this formula. Especially we need to know what happens to one particular ray which will be predicted by this formula, right? So here it is. This is the one of the important implications of this formula that we're going to use again and again, and that is that what happens to a ray that I'm going to use yellow ray. What happens to a ray that is coming from infinity on to the mirror? So what we mean by rays coming from infinity is that they all are parallel to each other. Okay. The reason the rays coming from infinity are parallel to each other is can be reasoned out backwards, in the sense that Mr. Ray 1 and Ray 2 both coming from a source at infinity means that they meet at infinity, and any two lines, if they meet at infinity, that means they're parallel, right? So here's a ray that's coming from infinity. So what we can say is u is minus infinity, because that's a sign convention. Now this means that 1 by u is nearly 0, because 1 over minus infinity is, well, nearly 0. Okay. Now what this means is that 1 by v is equal to 1 by f. Now what this means is that v is equal to f. Now what this means is that, let's say for this example, v is equal to some minus value, right? Because f for a concave mirror is negative, some minus value, in fact minus of the focal length. I'm just talking about modulus of the focal length, means, okay, I don't think you know what modulus is, but I think you understand. So v is negative, and it coincides with where the focus is. What does this mean? Now what this means is that the reflected ray passes through the focus. What also means is that the reflect this, let's say take one more ray now. This also passes through the focus. Okay. Now this is very interesting. Now what about the eye? Where is the eye? The eye is right here. Okay. And what does the brain think? Well, the brain thinks that there is something here. And when the brain thinks that something is here, that's the image. And where was the object? The object was at infinity. Okay. Now, in a sense, the main conclusion for you is that the rays which are parallel to the mirror and parallel to the so-called line that is passing through the optical center get reflected and pass through the focus. So basically we got a prediction of the reflected ray and the fact that it passes through the focus. And what is the focus? The focus is, you take the radius first. So this whole thing is the radius and half of the radius. So can I write it as r by 2? That's the place where the focal length is. Can we repeat the argument for a convex mirror? Right. So it's better for me to draw it all over again. So here again, I repeat the whole argument. There is a mirror. There is a convex mirror. And as our sign convention, the formula is of course the same, 1 by p plus 1 by u is equal to 1 by f. And this time what we're saying is the rays are coming from infinity and they're parallel. I think there is no need to repeat that argument. The reason that they're parallel is because they meet at infinity, and two lines meet at infinity only if they're parallel. And they're all coming parallel to this axis, which is passing through the origin. Now what this means is that a u is minus infinity. Now this immediately means, like previously, 1 by u is nearly 0. Now what this means is that v is equal to f. Now what this means is that v sorry, F is now positive. If you want me to draw it, remember that this is the radius, and half of that, something like here, is where the focus is. And remember that F is positive by the sign convention. Now what this means is that V is also positive. V is positive. Okay, so F is positive because it's a convex mirror. That's what I've written here. F is positive, and now this means that V is positive because V is equal to F, and what this means is that V is positive. Now what really happens is this. This time the rays are going to get reflected. Okay, and basically what the formula is saying is that this is what is going to happen. Okay, I'll convince you of this in a minute. This is what is going to happen. Okay, this one. What does this mean if this is true? What it means is, if there is an eye here, where's the eye? Okay, there's an eye here, here, and now what the brain thinks is that it's going to project these two rays behind. So the brain thinks that there is something here. There is something here. Okay. Now this is the image. Where was the object? Yeah, of course, the object was at infinity. And there is a point object at infinity, and the eye sees it as a point object at this focus, which is to the right of the mirror. Okay, so such a mirror, such an image which is to the right of the mirror is called virtual. And the previous time, oh my god, I should have mentioned this. The previous time, the image was to the left of the mirror. Image to the left of mirror is called real. And if the image is on the other side of the mirror, inside the mirror, a world inside the mirror, then we say that the image is virtual. Okay, but more importantly, what I want you to notice is this, and I'm going to summarize it as a last slide. I think what I really want you to remember is this, that there are some rays which we can predict easily in both the convex and concave mirrors, and possibly this is going to be very useful for us when we get down to our business of predicting things, and we're going to get to that very fast. So the main thing is this. So if the rays are parallel, to this x-axis, where this is the optical center, if the rays are parallel, then it's very easy to predict the reflected ray, and the reflected ray is simply going to pass through the focus. Okay, and the reflected ray is simply going to pass through the focus. Now this is the prediction. The red line is the prediction, and the yellow line is the incident ray. Okay, so this is the incident ray, and without much difficulty I'm able to predict the reflected ray. And here, you know what's the story. It's going to come like this. Let's say the focus is here, then we're going to be able to predict the reflected ray very easily. You just join this to the focus, and then you extend the line. So this is the reflected ray, and this is the incident ray. Okay, so this is what we learned today. There are some rays which are easy to predict on reflection from mirrors, and once again I would like to remind you that we based our analysis on the single formula called the mirror formula, and This is coming from one law of physics called law of reflection, and there is a good use of geometry for the proof, which we shall get into at the end of the chapter. Right now, let's focus on doing the formulas. And what is important here is A, sign convention, and B, units. Please remember that um, units, we'll keep reminding ourselves to make sure that we are very good in units. That helps a lot in physics. As you will see, you will make very less mistakes if you're constantly keeping track of the units, so it becomes a habit. Okay, in this case things are not very difficult, so I'll catch up with you with another video. Meanwhile, you please see this video and let me know if you're finding it difficult to follow when we meet up tomorrow. See you. Bye.